Hello everyone, my name is Patrick Liquete, your nursing school tutor, and today we're going to be covering our segment on your intro to interpreting cardiac rhythms. So this is an intro course and we're going to learn basically a little bit about the anatomy of the heart, how the electrical conduction affects the mechanical component of the heart, and what do these all mean in your regular EKG strip, right? So let's take a look at a little bit about the conduction system of the heart. So to simplify this a little bit, the conduction system means the electrical system of the heart. We need electricity to run through the heart, as you can see here, to make it do its mechanical movements. So think of it as like a car battery, right? With the car, you have a car battery and you have the engine. With the car battery, it gives the electrical output of the car, while the engine itself creates the movement. We're only going to be talking about the electrical output here. So a little bit about the anatomy of the electrical conduction is we have these things called pacemakers. What do we mean by that? You've heard of the pacemakers that people wear outside in public, right? They have little pacemakers, but your heart, that term stems from the term inside your heart called your pacemakers. So our heart has basically a couple pacemakers. The main pacemaker is your sinoatrial node, or in short, SA node. That is called the pacemaker of the heart. It gives about 60 to 100 beats, which if you relate that to your vital signs, if you check someone's heart rate, it's going to be about 60 to 100 beats. Now, that's going to be located on your right atrium, right, above the right atrium. Now, that sends its signal down to the atrioventricular node, or in short, the AV node. The way you distinguish it is by the name atrioventricular. Atrio meaning in between the atrium, and ventricular is ventricle. So in between the atrium and the ventricle. So atrioventricular node. Now, this conduction system goes down to what we call the bundle of His right here. The bundle of His, and that's located in the septum, which is the middle portion that separates the right and left side of the heart, and all the way to the Purkinje fibers onto the side, right? So your AV node by itself can output about 40 to 60 beats. So if your SA node does fail, your AV node tends to take over and gives about 40 to 60 beats, which people can still survive off of. And of course, the Purkinje fibers here, as the last resort, if your SA node fails and your AV node fails, these Purkinje fibers in the bottom can give out about 20 to 40 beats, which is not ideal for the survival of the human body. So we'll talk about that a little bit as well when we reach on to your abnormal heart rhythms. Now, you've seen these strips, whether in movies, in shows, and you see it on monitors all the time. And you might be wondering to yourself, what the heck does this all even mean, right? It's just nothing but lines to me. Well, with these lines, we are reading the electrical output of the heart, right? Where these are called deflections. So every time there's an electrical output, we're reading that. We are not reading the actual mechanical beat. I want you to understand that. The heart itself does not have to be beating for it to have electricity running throughout of it, right? So whatever we're talking about, the electrical output, there's waves. So we're going to call this your PQRST wave, okay? Don't mind the U just yet. We're going to talk about the PQRST wave. That is the segment, that is the section that you're taking a look at, and you're taking a look at all these components. So let's take a look at some of the components that you need to see in basically the most standard basic things you need to find. All right. So we have your P wave to start. Right. We have your QRS, and then we have your T. I want you to separate those into three segments right there. So your P wave, right? Your P wave. Think about that as the top portion, your atrium, right? Your atrium contracting. One word for contracting in ionic terms is depolarization. So contracting, your atrium is contracting. Now, it's going to switch out to the QRS. Now, the ventricles start contracting while the atrium relaxes. The ventricles start contracting. That's called ventricular depolarization. That's why that deflection is so big, right? It's such a big spike. It's sensing that giant ventricular beat. Now, the T wave, it's going to be ventricular repolarization or ventricular repolar relaxation. Okay, ventricular relaxation. Again, you have your P wave, which is the atrium depolarization, atrium contracting, the QRS, which is your ventricular contraction or ventricular depolarization, and then your last T wave is when your ventricles relax or repolarize. Now, you might be wondering where that atrium, right, relaxes. It's going to be hidden in that QRS. So whenever that atrium beats and the ventricle beats, that atrium is relaxing. So you don't really see that on the wave. It's hidden in this. So you're going to take a look at that PQRST wave to see if it's complete. Now, a couple key components to look at are measurements. Now, the normal PR interval, right? We're going to take a look at these measurements, but let's move forward here a little bit just to take a look. So this is just a summary of what I talked about. That P wave is the atrium contracting right up top here. That QRS wave is that ventricular contraction, and then that T wave is ventricular repolarization or relaxation. Okay. Now, we're going to take a look at some of the measurements you need to find. So first things first, you need to find the heart rate, right? You've learned in vital signs that the normal human body heart rate is about 60 to 100 beats. So that's what you're looking for, 60 to 100 beats. Now, as you can see here, I put a couple measurements right up top. Each tiny little box is going to be worth 0.04 seconds. Okay, 0.04 seconds. That's one of the main units of measurement you're going to take a look at. Now, some measurements that you need to find before being able to distinguish certain heart rhythms are what we call your PR interval. You're going to take that very initial portion of the hill before the P wave starts. You see that hill? You're going to take that first initial line and you're going to measure it all the way to where the beginning portion of that Q. That is called your PR interval. That's one very important measurement we need to find. So your PR interval is going to be 0.12 to 0.2 seconds. 0.12 to 0.2. I remember it as decimal of 12 to 20. That's one way I remember it. That's an easier way, right? Now, if we look at the measurements here, 0.04 seconds, that's going to be about 3 to 5 boxes, all right? 3 to 5 boxes long, okay? Now, next measurement you're going to find is your QRS interval. That is from the start of the Q to the end of the S. QRS interval. That should be about 0.06 to 0.1 seconds, or 6 to 10 decimals, right? So you're going to take a look at that. That's going to be about a box and a half to about 2.5 boxes, right? So that's one thing you're going to take a look at. So another thing you're going to take a look at is this, what we call R to R. So from the top portion, which is this top spike, we call those the R's, right? We call those the R's because that's the top portion of that spike. You're going to measure one R to the next R, right? You're going to measure one R to the next R, and you're going to take this section and make sure that it's measuring up to the next section. So we'll talk about that as well. So whenever we're distinguishing rhythms, there's a systemic approach to how you should find these things, right? There's a systemic approach to how you find these things, and you need to determine these components before we can distinguish what a rhythm is. So first things first, we're going to take a look at that rate, right? We're going to take a look at that rate, 60 to 100. You need to find out how much it is. As you've learned in your vital sign, below 60 is bradycardia and above 60 is tachycardia. You need to find that rhythm, which we measure by R to R. We're going to take this one R. So let's take a look at that real quick. So we're going to take this measurement of one R, and we're going to make sure that it's the same measurement from the next R to the next R, right there. So that's one thing we're going to take a look at. Now, when we move to, we're going to find out if there are P waves. So what you want to look at is, do we have these things, the P's? And you're going to find that on each one. Do we have these P waves, right? You're going to take a look at that PR interval. And as we said, it should measure about 0.12 to 0.20 or about 3 to 5 boxes, right? Now, you're going to take, is there a P to every QRS? Is there an atrial beat to every ventricular beat, right? Because if the atrium beats, you need the ventricle to beat as well, right? And you need to find out the QRS rate, which is the heart rate. And of course, we'll talk about if there is a pacemaker as well. All right, first things first that we got to do, you find what we call a 5-second strip, or 6-second strip, sorry. We find what we call a 6-second strip. You're going to see these lines located at the top of the strips. And each, from one line to one line is about 3 seconds. You're going to take 2 of these lines, okay? And you're going to measure all the R's. So the way we do this is taking a look at the top of the R's, counting these R's, right? Counting these R's. So let's count this. 1, 2, so if we count this, sorry, let's see. If we count this, there's about 1, 2, 3, 4, 5, 6, 7, 8. There's about 8 R spikes. We're going to take that R, right? And since this is a 6-second strip, to be able to distinguish a minute, we need to multiply that by 10. So taking 8 and multiplying by 10 gives you 80 beats per minute. Now, a couple caveat to this is if you do not see the top of the spike, you do not count it in that 6-second strip. Meaning, if all you see is this, is part of that R, and you don't see the spike, you don't count it. But if you see a spike, right here, if you see a spike, you're going to count that spike, all right? You're going to count the spike. So only count the spikes. So that is one way we're determining, and this is called the 6-second method. This is the most easiest way to count basically your heart rate when looking at EKG strips. Okay? So that's your intro into reading these basic EKG strips. Follow the next parts. On the next segment, we're going to be talking about how to distinguish your sinus rhythms, normal rhythms, and basically some abnormal atrial rhythms. So that's gonna be what's in the next component. So follow part 2 if you want to continue this.